Now let's talk about the security aspects of Lambda function. So in this topic, I'm going to discuss some of the best practices we should be following while designing the security around AWS Lambda. The first rule is that you should always have one IAM role attached to one function. You should not be sharing the same role with multiple functions. Taking an example, let's suppose one of the Lambda function needs access to the KMS keys. Now, if you share the same role across the Lambda functions, then all the functions will be having access to this same encryption key. So, always try to have one IAM role per function. That will ensure that you have the least privileges providing to the function. The second one is credential management. So in most of the cases, the IAM execution role itself should be sufficient to have you connect your Lambda function to other AWS resources. You just need to use the AWS SDK without providing the uh, secret credentials in the code and connect to that. And the Lambda will take care of automatically retrieving the temporary credential for that service based on the role access you have defined, and then use that temporary credential to connect to that resource. But in some scenarios where, let's suppose you want to connect to the cross account services. So let's suppose you have one VPC where you are running your Lambda function. Now you're connecting to a PostgreSQL database which is running to the another VPC. Now in this case, you would need some credentials to access to that AWS resources which is sitting in the different VPC. In that case, instead of hard coding the access key and secret key in your code, you should be using the AWS security token service, and that service provides a API called assume role API. This API can generate a temporary credential and give it back to you. You can use this to connect to the AWS resource, and it has a timeout uh, feature, so it will be active only for a particular duration. After that, it will expire. So that is the best practice you can follow to connect to any other AWS resources using the temporary credentials. Now, in some scenarios, you would need to keep the long-lived secrets also, where you cannot afford generating the keys again and again. Like take example of connecting to a database where the credentials have been generated one and you want to keep it for a long time. You don't want to keep getting the new credentials for the database, right? So in those cases, what you can do is you can put those secret credentials in the environment variable. Lambda, it provides a feature where you can encrypt those variables using the helpers. So you can use the AWS KMS key. Uh, so if you look at this, here you can add any password credential and put the password as test, and then you can apply the AWS KMS key to encrypt it. So if you can create your own custom master key, you can use the default key as well, and that Lambda will handle to encrypt this key, and then you can use that in your code using the AWS SDK, and then connect to that particular resource. You can even click on the button code to get the code for decryption, which you can use to decrypt the credential which you are setting up to the environment variable. So this code you can use it to decrypt and use it to connect to the database or any other AWS resources for which you are setting up this credential. So that is for the persistent secret to store. There is another option is called SSM, which is Secret Service Manager. This service is also used to store the credential with the AWS KMS key, and there are a couple of other options as well. The difference between the environment variable and SSM is that the environment variables are very tightly coupled with the function. So if you want to change the credential for a function, it will publish another version of it. So it will bump up the version when you are updating your credentials in the Lambda. And that's why you have to make the do the version management in that. You need to point your alias to the latest version. But the SSM is totally decoupled from the Lambda function. It is a service which you need to call from your Lambda function to retrieve the credential. So there are advantage and disadvantage in this, right? Because if you're using the environment variable, it will be very fast because there is no extra code you have to write. It is just you have to load the environment variable. But in SSM case, you have to make one external service call. You have to write extra code and it will add up to your computation as well. But it is more decoupled from your Lambda. The third topic is about VPC security. Right? So as we know that Lambda function can be run on VPC as well. So in that case, you need to apply all the VPC level of security. There's a detailed documentation provided by AWS how to secure your VPC. But high level, you need to ensure that you are putting proper subnets, Lambda function specifics only. You need to ensure to define the security groups, ACLs. So all the security standards you have to follow as per the VPC. Next topic is deployment access control. So when we set up the CI/CD for Lambda, we will be mainly calling two APIs. One is update function code and one is update alias. So when you do call update function code, it is nothing but a code deployment where you will be updating your code and this API to call to get it reflect the updated code for the Lambda. And the update alias is where you are bumping up the version and pointing to the latest version. So it is something similar to code release. So these two APIs are very sensitive, very critical because it can impact your customers as it will reflect the new code into the production. And so you have to be very careful about providing the access to these two APIs. Ensure that these APIs are not accessible by the normal users with the direct access. It should be only allowed to get access through the automation of the CI/CD. So that is all about security of the Lambda function.